pre-algebra students, Mr. Lawrence here, and we're going to continue our exploration of polygons. And this is going to be kind of like a review, but there's going to be some new material in here as well. And first of all, let's get started. We are going to name this polygon. Now remember, we name it by the number of sides, and there are 1, 2, 3 sides. So the name is, of course, a triangle, right? Now, real basically, how many triangles are there in a triangle? Well, there's one. So that means the total number of degrees would be 180, because there's 180 degrees in every triangle, times how many triangles are. I see one. Total number of degrees is 180 degrees. All right. Now we have to find the measure of one angle, assuming the triangle is regular. Assuming it's regular. It must be regular for that to be true. All right, so the measure of one angle. Well, we're going to take the 180 degrees and we're going to divide it by the number of angles. I see 1, 2, 3 angles. So we're going to divide by 3. So that means the measure of one angle is 60 degrees. Okay, now here comes the new part. I'm going to go off on a small tangent for a second. Would be surprised if you don't know how many degrees there are in a circle. Okay, I think most of you know that there are 360 degrees in a circle. How many degrees are in half a circle? Like if I draw a diameter of that circle, it's across the middle through the center. Well, if the whole thing has 360, doesn't one of the halves have 180 degrees? Right? And that is 180 degrees. I've got a strange question for you. Do you know how many degrees are in a line? You should. You should be able to tell me based on what I just said. But if you don't, let's go ahead and take 2 squares. Let me get a square out here. Okay, I've got a square. And I'm going to clone him. Okay. And I know that each square has a right angle, has 4 right angles, right? So that's on right angle. So that's 90 degrees. And then this is a right angle, and that's 90 degrees. Now what would happen if I put those together? It's not picking everything up, but let's see if it'll move. No, it won't. Hold on one second. Okay, so now if I slide this together here, I have 2 90-degree angles right next to each other, don't I? I sure do. And 90 and 90 is 180, right? Well, what's this right here? What is that? The bottom of those 2 squares. Doesn't it make a line or a line segment? And look, there's 180 degrees there. I ask you again, how many degrees are there in a line? Hopefully you're able to tell me there's 180 degrees in a line. Okay, now why is that important? Well, watch this. This is the interior angle. It's on the inside of the triangle. I'll call it A. Okay, I can figure out the measure of the exterior angle. If I extend this segment here, for some reason I'm stuck in highlighter mode. There we go. I can figure out the measure of angle B. Yeah, I sure can. Well, I know that the measure of angle A is 60 degrees because I figured that out over there. I know that there's 180 degrees in a line. So I can take 180 minus 60 and get 120 degrees. Angle B is 120 degrees. So that's the measure of an exterior angle equals 120 degrees. Pretty simple stuff. Let's try it with a stranger shape, one that's not so friendly, like this giant of a guy here. I don't know what to call this guy. I better count his sides. Let me go ahead and count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this guy's name is a 15gon. Okay, I'm going to do the next step the hard way, and hopefully you'll start to see an easy way. If not, I will point it out to you. Okay, this is where I break my shape up into triangles, right? So I'm going to circle one of the vertices, and then I'm going to draw segments to every other vertex that doesn't have one. So there's one triangle, there's 2 triangles, 3 triangles, 4 triangles, 5 triangles, 6 triangles, 7 triangles, 8 triangles, 9 triangles, 10 triangles, 11 triangles, 12, and 13, because I created 2 there, didn't I? So I've got 13 triangles. So to get the total number of degrees, first I should get into pen mode, huh? The total degrees, I'm going to take 180 and multiply by 13. And that'll give me the total number of degrees. So I'm going to get a 4, got 3, and 8 is 11, and 2 is 13, carry the 1. I think that's right. I'm going to check it really quick, because if that number is wrong, all my other numbers will be wrong. Hold on one second. Okay, so that I verified that number on the calculator, and that is correct. All right, so get rid of my work there because it's in the way. I don't ever want you to erase work. I'm just trying to keep all my stuff condensed. Okay, so how big is one angle? I need the measure of one angle. Well, the measure of one angle, assuming that it's a regular shape, okay, will be 2,340 divided by how many angles there are. Well, it's a 15gon. There must be 15 angles. So when I divide that, I get 156 degrees. There we go. It's 156 degrees for the measure of just one angle. All right. Now, what that means is, let me get rid of this segment here. I know that this angle right here is 156 degrees. Pretty big angle. And I can figure out the measure of this angle. I'll call it x, this exterior angle. How do I get that? Well, the exterior angle will be 180 minus the 156. To do some borrowing, get a 4, going to get a 2. It's going to be a 24-degree angle. 24 degrees. So x is a 24-degree angle. So 240, that's 24. Oh, that's looking worse. Hold on. There we go. That looks a little bit better. Okay, so we've found the measure of an exterior angle now. Okay, now here's another shape. We're going to do this one more time, but we're going to do it an even easier way. We're going to count the sides. I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a 13gon, right? Now, I don't know if you've noticed this, but let's see if we can find a pattern here. When I had a triangle, there were 3 sides and 1 triangle, right? When I have a quadrilateral, there's 4 sides, but when I divide it up, there's 2 triangles, right? Okay, when I have a pentagon, 5 sides, and there's 3 triangles. Do you notice something here? If I had a hexagon, well, that's 6 sides, right? How many triangles do you think there will be? Well, 1, 2, 3, 4. 4 triangles. Do you notice that the number of triangles is always 2 less than the number of sides? I said the number of triangles is always 2 less than the number of sides. The number of triangles is always 2 less than the number of sides. The number of triangles is always 2 less than the number of sides. So this is the 13 gone. I'll bet you that means there are 11 triangles, which means I'll take 180 times 11. Oh, 180 times 11. And let me see here. 1980, I think. Is that right? 80 times 11. Yeah. All right. So that means the total degrees is 1980. Okay. The measure of one angle, if it's a regular polygon, will be 1980 divided by 13, because there's 13 angles. So divided by 13 gets me 152 point, and I'm going to go to the hundredths place, 31 degrees. Okay. Now, remember that means that this angle here is 152.31 degrees. Of course, that's a rounded answer. To figure out this angle here, I will take 180 minus the 152.31. And I know that's going to equal 0.69. And what's that going to be, 28? Yeah, I believe so. So the measure of an exterior angle when the shape is regular will be 28.69 degrees going to the hundredths place. And there you go. All right, you may want to watch that again, but that is the lesson for today. Mr. Lawrence signing off. Good night, everybody.